Hi guys, and welcome to Journey Through to the Centre of the Earth. This is Activity 5 for Year 9, where we're going to look at what happens when continental plates collide together. Now what we've got here is a diagram of two continental plates. You can see with the cursor, we've got one on the left-hand side, and we've got one on the right-hand side. And you can see by the arrows that they're pushing against each other. So one basically is pushing from left to right, and the other is pushing from right to left. Now three things are going to occur when we get two continental plates colliding. Now the first thing that we're going to notice is that one plate is going to slip underneath the other. Now you can see here at number 1 we've got the left hand plate which is slipping under the right hand plate here, and this produces what we call a subduction zone. Now once that plate slips under, it's going to continue slipping under. It's not going to change that the other one takes over. Reason being, you've got kilometers of rock all pushing down in the same direction. The chances of moving that around are very, very slim. Okay. As a result, what we then find is that the second plate is going to be pushing up and over. Now, due to friction, what will happen is this landmass will begin to bulge, and as it begins to bulge, what we'll get is production of these mountains. Now, this is due to uplift as the rock is beginning to slide up and over. So we get this pushing up of this rock. Now often this rock can be particularly hard, or sometimes it can be soft. Now what we'll find, and we'll see an example of that in a minute, so often this can be areas that were once at the seabed, and the result is it's all pushed up. So what we've got is huge amounts of pressure behind this this number 2 here, huge amounts of pressure pushing this rock upwards, and friction is generating this massive uplift as it moves across. We may get a trench which is formed along this side here, where you can see where the cursor is, just where this dips down. But more often than not, it's going to look like large hills which are beginning to generate. Now the third thing that's going to happen is behind this massive pressure, we're going to get what we'll call a high plateau. Now this is because we've got all this plate pushing up against these mountains, and the result is this high plateau means that we're going to get this gradual incline as we move back down to the plains. Whereas here, they're going to remain, you're going to get probably a really good sheer rock face, which is going to generate because of these new rocks which are being formed here. So, three things we need to be aware of. One plate slips underneath the next when we get two continental plates colliding, forming a subduction zone. We get a range of mountains which are going to generate, and we get a high plateau on the area where the plate is not slipping underneath. So where's an example of this? Well, a good example is the formation of the Himalayan mountains. Now this happened around about 50 million years ago, and it was a direct result of the Eurasian plate crashing into the Indo-Australian plate. Now in between the two of these was the Tethys Sea. Now if you remember back to our continental drift activity, the Tethys Sea sat between India and Asia. Now, with time, the two plates came together, huge pressure, forced the water out, it just flowed away, and the result is we got massive uplift. The Indo-Australian plate slipped underneath, the Eurasian plate pushed up, and the result is we then got these mountains. Now, these mountains basically now are under immense pressure. Due to folding, the mountains push up, and as a result we've got the Himalayas. So if you think about the Himalayas, that's got Everest in it. Now Everest basically is the tallest mountain we've got on Earth. Now the result is that was once under the sea. Why? Because it was under the Tethys Sea. So as a result, you can see this idea that we've got the Himalayas being formed due to the Eurasian and Indo-Australian plate crashing into each other. The Tethys Sea disappears. We then get the seabed, which is then pushed up due to folding, and as a result, we get our mountain ranges which are formed. Okay, well, that finishes off our work on what happens when continental plates collide. I hope that was useful to you. Join me again, and we'll see what happens when we have other plates having collisions. Thank you for watching.